Okay, let's have a look at points of inflection. So want you to try and investigate the graph of y equals x cubed, and we're going to find any local maximum and minimum points. So what we need to do is we need to take that and we need to differentiate the first time, and we'll put it equal to 0, and we can see that if x equals 0, x equals 0 at 0, so there are possible maximum and minimum values. Now that's not for sure, we need to investigate further. So then we differentiate again, and we find that we have 6x. 6x equals 0, so x equals 0. Now remember, maximum points were when the second differential was negative for the value where you thought you had the maximum, and they were positive for where you thought you had the minimum value. But here we've got 0. Now this tells me that there are no local maximum minimum points. In fact, it's indicating that we have a point of inflection. So what is a point of inflection? So a point of inflection is where the tangent flips over and goes from being on the inside or the outside of the curve to the inside or the outside. So here the black lines are the tangents, and at 0, just about at 0, we have this horizontal tangent, which is y equals 0. And then you can see from being above the curve, the tangent flips to be below the curve. And that's an inflection point. So how can we tell if we've got an inflection point? Well, we have the second differential, make it equal to 0, and we solve it, which is what we did back here. We made the second differential, basically we made it equal to 0, we solved it. And what that told us was that there's a possible inflection point, but we've got to do some more checks. So this is what we do. We put the value of 0 in here. We want to look either side of 0. I don't want to go too far away. So I've chosen either side of 0 is -1 and 1. We check what the sign is when x is -1. So -6. I'm just interested in whether it's negative or whether it's positive. If it's negative and then it goes to positive, or the other way around, then we have an inflection point. If it was negative, negative, or positive, positive here, we do not have an inflection point. So we've got to check. Further, if it's negative, down, concave down. And if it's positive, concave up. And this is what concave down and concave up mean. Concave down is when the curve is down and the tangent is on the upper side of it. And concave up, the tangent's below the curve. Okay, so the curve is concave up. And there's our point of inflection. So there's a quick image to give you an idea. And then you can also see it graphically. So if the red one is y equals x cubed, I've differentiated. Now where it equals 0 is that point of inflection. And you can see that it doesn't cut through 0. So we don't have maximum minimums. But the second differential goes from a negative to a positive, or from a positive to a negative. If we get this occurring graphically, where we're going and seeing a sign change around our point of inflection, then we do have a point of inflection. Now there are times when we don't have points of inflection, and the next couple of questions you could have a look at where we have points of inflection and where we don't have points of inflection.